Hello class, this is Mr. Gottlieb. Once again, this is Unit 9, Day 8. I know the worksheet says Day 7, but yesterday was Day 7, so this must be Day 8, and Mr. Gottlieb must have made a mistake. So today what we're doing is we're evaluating trig functions for the measurements 0, 90, 180, and 270. And these are different from all the other trig functions because literally every other angle will form a right triangle on the circle. So for instance, if this was our central angle in standard position, if I drew an angle here, we make a right triangle here, and this is our reference angle. But that doesn't happen if we use any of these other angles. So if we were to use, for instance, towards the bottom here, this is 90 degrees. We have to make a triangle using our terminal point and the x-axis. This is not a triangle, this is a line. Similarly, if we were to do it for 180 degrees, this is our terminal point, and this is the x-axis. We just get a line. So we can't do what we were doing before. There are no reference angles here. So we have no reference angle on any of these. So there's going to be a different way for calculating those. But before we get into that, let's talk about the do now assignment. So the do now assignment says, show that x squared plus y squared equals 1 for each of these three triangles. Now, it's really x squared plus y squared equals 1 squared. But this works because the hypotenuse of these triangles is 1 because we're using the unit circle. So, and you'll notice that x and y, as we said before, are the coordinates where the terminal side intersects the unit circle, and x is also known as the cosine of theta, and y is the sine of theta. This is going to be very important for today's lesson. First, let's run our test here. What's x squared plus x squared plus y squared equal 1 squared? Well, the square root of 3 over 2 squared plus 1 over 2 squared should equal 1, or 1 squared. It really doesn't matter. Radical 3 over 2 times itself. We have radical 3 times radical 3, which is 3. 2 times 2, which is 4. Plus 1 times 1, which is 1. And 2 times 2, which is 4, equals 1. That we get 4 over 4 equals 1, which is a true statement because 4 over 4 is 1. And the same thing will happen if we do this for the 60-degree angle, because we will just have the x and y value switched. You'll have to try both the second one and the third one on your own. Anyways, on to learning about the other angles today. So the angles we were using yesterday were 30, 45, and 60, which create reference angles because they create right triangles. Today we don't. We just have we don't have reference angles, so we're to call them coterminal angles. So like 0 is coterminal to 360 and 720, and every time we add 360 we get another coterminal angle to that. Now, all angles that are 0 or 360, so we're going to actually start at 90 just because of the way I drew the triangles below, or the circles below. So the sine of 90 degrees, according to my calculator, is 1. All right? The cosine of 90 degrees, according to my calculator, is 0. And the tangent of 90 degrees is an error, so that is undefined. So it's undefined. Now let's go into why all of these things are what they are. So as we said before, the coordinate where the terminal ray intersects the unit circle is xy, which is also cosine of x, cosine of theta, and sine of theta. Our angle in this case is 90 degrees, so this is theta, it's 90. And the x value here is 0, and the y value is 1. So that means the sine of 90 is 1, and the cosine of 90 is 0. I'm sorry, the cosine of 90 is 0, the sine of 90 is 1, and tangent is undefined because, as we said before, tangent is the opposite side, which in this case is the y value, and the x value is 0 in this case. It's y over x. So tangent is y over x, so it's 1 divided by 0, which is undefined. Therefore, tangent of 90 is undefined. Do the same thing for 180. So sine of 180, whoops, I think I entered sine twice. Try this again. Sine of 180 is 0. Cosine of 180 is -1. And the tangent of 180 is, whoops, I just wrote 180. Let me try that again. Sine of 180 is 0. Cosine of 180 is 1, oh, -1. And the tangent of 180 is 0. So that was 0, -1, and 0. Now to get into y, we're going to take a look at our circle here. At our coordinate, we have the point -1, 0, which should explain where the -1 came from. Just like we were talking about yesterday, where the different quadrants, only certain trig functions are positive or negative in these quadrants. That's what's happening here. In this case, the cosine value is negative on this axis, on this side of the axis. So cosine of 180 is -1. So this is the cosine. The sine is 0. And 180 is y over x, right? So y over x in this case is equal to 0 over -1, which is equal to 0. All right. 270, we have this coordinate down here, which is the point 0, -1. So by prediction, this is cosine, so cosine of 270 should be 0, and sine of 270 should be -1. So -1, 0, and the tangent is going to be y over x, so -1 over 0, which is undefined. Let's just test it on a calculator. Sine of, let me clear it first. Sine of 270 is -1, which is what we said. Cosine, whoops, double cosine. Cosine of 270 equals 0, and which is what we said. And the tangent of 270 should give us that domain error. So that one worked. And for 360, we have this point here. It's also 0, so this is 360 or 0, 0 degrees, or 720, whereas 270 is the same thing as 270 plus 360, so it's 270, and if I add 360, that's 330, 630, so 630 would have the same values. So this coordinate is 1, 0, so again, y is sine, so sine of 360 is 0, which also means that this is 0. This one should be 1. This one should be 1 because they're the same. 0 and 360 are the same. And the tangent is going to be 0 over 1 or 0. So this should be 0 as well. And that's the basic idea of what we're doing today. The back is just a collection of practice problems. I'll just briefly go over one angle that's not coterminal to 090, 180, and 270 from yesterday's work, just as a reminder. So I have the full list of angles. 0 and 90 are two of the ones we just talked about, but yesterday we would have talked about 30, 45, and 60. These are the angles that are formed when you have a reference angle. So let's take a look at tangent of 2 pi over 3 radians. Well, I can convert this into degrees if that helps me. So that would be tan 2 pi over 3 radians. I'm going to convert that into degrees by multiplying by 180 degrees over pi radians. What happens here is that the pi's cancel out, the radians cancel out. I get 2 times 180, which is 360, divided by 3, which is 120. So this is the same thing as saying the tangent of 120 degrees. If I were to take a look at the circle, 120 degrees is somewhere over here. And the reference angle would be the angle formed over here. So that reference angle should be the remaining, so this is 120, this should be a remaining 60 degrees. And since tangent is negative in this quadrant, because it's all students take calculus, tangent's only positive in quadrant 3 and quadrant 1. So this should be equivalent to negative tangent of 60 degrees, because that's the reference angle. So the reference angle is there is 60. And the tangent of 60 degrees, which I don't remember what it is from my table, is radical 3. So this should be negative radical 3. You should also, on your calculator, just be able to type in tangent of 60, not 60, tangent of 120, and get negative 1.732. And if you remember, negative 1.732 is radical 3, and the fact that it is negative means it was negative in this quadrant. Now we could also do this in radians. We could just press mode and put our calculator in radian mode. Getting out of modes. I can type in tangent of 2 times pi. Whoops, pressed the wrong button. Tangent of 2 times pi divided by 3. Whoops, wrong button. 3. And now it should give us the same answer. But it only did that because we put it into radian mode. So if you want to use radian measure, you just need your calculator to be in radian mode. Anyways, that's going to wrap up today's lesson. If you have any questions, make sure you ask them either on the Google Classroom or on PupilPath, and I will help you to the best of my ability.